3 blocks are supported using the cords and 2 pulleys shown. If we have that WA is equal to W, WB is equal to 0.25 W, and WC is equal to W, then we need to find the angle of theta so that this is in equilibrium. All right, our free body diagram is just going to be of this knot. So we have our knot here at A, and we have W here because WC is W and it's on a pulley, so this has to be the same. Similarly, whatever is here at B, which we have is 0.25 W, has to be the same as what we see here. So this is W at an angle of phi, and then this we have 0.25 W at an angle of theta on our axes here. Oops, it's not very straight. And then our weight W coming down. So we have those 3 forces. Working on our equations of equilibrium. The tricky part of this one is we have to be comfortable just leaving W in there as W. And it'll work out. We just have an unknown W. We're leaving it in there until the end, or until we get rid of it. So the sum of the forces in the x direction is equal to W, starting with this guy over here, W times cosine of phi, and that's positive, and then minus 0.25 W times cosine of theta is equal to 0. I'm going to get one of those out. W cosine of phi is equal to 0.25 W cosine of theta. And then these W's can be taken out, or divide everything by W, so they're gone. And then I'm going to multiply everything by 4 so that I have 4 cosine of phi is equal to cosine of theta. It's just prettier, nicer, and I'm going to call that my first equation. Then I'm going to do the sum of my forces in the y direction. That will be negative W for this piece, plus W sine of phi for this one, the y component of that, plus 0.25 W times the sine of theta for my y component of this force, all set equal to 0. Working through this so that I get my signs on one side and something that I can work with later. I'm going to bring this this component in this piece over to the right, so I have 0.25 W sine of theta is equal to W minus W sine of phi. I'm going to take out divide everything by W and multiply everything by 4 so that I have sine of theta is equal to 4 times 1 minus sine of phi. And that's my second equation. So what I need to do here is I'm going to use the Pythagorean theorem that says that the sine squared of theta plus cosine squared of theta is equal to 1. Solving then this for sine of theta, I have the sine of theta is equal to 1 minus cosine squared of theta, the square root of all of that. So I'm going to then stick this into my second equation. So I end up with the square root of 1 minus cosine squared theta is equal to 4 times 1 minus sine of phi. And now I'm going to sub this into equation 1. One minus 4 cosine of phi squared, or subbing this, sub in equation 1 here. Not into, but I'm using equation 1 and subbing it into this, is equal to 4 times 1 minus sine of phi. All right, last I had was 1 minus 4 cosine phi squared is equal to 4 times 1 minus sine of phi. So now all I have is phi's. So that's really handy because I substituted my first equation into my second equation after I used the quadratic. Now I'm just going to do some manipulations, algebraic and trigonometric. I have 1, multiplying this out, 1 minus 16 cosine squared phi. That's what happens when I square this here. That will be equal to 4 times 1 minus sine of phi. Taking this out, I'm going to square both sides. So I need to square both sides here. I will get 1 minus 16 cosine squared phi is equal to 16 minus 32 sine of phi plus 16 sine squared of phi. And so that I can use the Pythagorean theorem again, I'm going to get these two together, move everything else over. So I'm going to move this over to the right. We have 32 sine of phi. And then I'm going to move this 1 over. So I have 15 here plus, and I'm going to put these in parentheses so you can clearly see it. Put the 16 sine squared phi with my 16 cosine squared phi. And then because of the Pythagorean theorem, this is 16. So I get sine of phi is equal to 31 over 32. I have 15 plus 16 is 31. Divide everything by 32. So I get this. And then subbing that into equation 2, I have sine of theta is equal to 4 times 1 minus 31 over 32, which is 1/8. And so theta is equal to 7.18 degrees.